Hello and welcome to the presentation of our paper entitled Optimizing an Ecological Farming Plan Using Linear and Goal Programming Methods. I am Talib DAMIJ and I am going to make a short presentation of this paper. Farm planning is a complex task because of several constraints and limitations in this field, such as land, labor, and capital. Land is an essential resource because there are different types of land that need to be wisely partitioned in order to plant different crops. Labor is another important constraint that impacts the farming expenses. Capital is a crucial limit to farm planning. In addition to these constraints, in ecological farming, farmers facing several problems in comparison with conventional farming, such as lower production, bigger amount of waste, and consequently higher product prices, lower profit, and other problems. Table 1 shows the data used in this work. We got this data from the owner of the well-known and medium-sized ecological farm in Dol, near Liljana, Slovenia. In the rows of the table, we showed 8 crops. And in the columns of the table, we showed key information related to these crops, such as human labor, machine labor, land restriction, production, expenses, and profit. Solving such a difficult problem is complex without using optimization methods such as linear programming method and goal programming method. In this paper, we described these two methods and how to use them. We developed 2 models and compute them using a simplex approach of Excel solver. We got 2 solutions, and at the end of the paper, we made a comparison between these 2 solutions. Linear programming is well known, and it is most common used method to solve different optimization problems. We show on this slide the standard form of linear programming model, which will consist of the objective function Z to be maximized and set of constraints specified on the basis of the data given in table 1. Z is the objective function. Xj are input variables, and Cj in the objective function are cost coefficients of the objective function Z. Bi are constraints where I goes from 1 to m constraints. A, ij are coefficients of the functional constraint equations. Based on the data given in table 1, we developed this linear programming model. The model consists of 13 constraints in addition, of course, to the objective function. The first 5 constraints are profit, capital or expenses, human labor, machine labor, and land size. And in addition to this constraint, we have 8 constraints which define the land size for, which specify the land size for each crop. For example, X1 represent crop spelled, okay, and so on. Goal programming method is very important actually, because farmers are often faced with several goals simultaneously. This is the formulation of the goal programming model. In this formulation, we see that we have 2 types of variables, decision and deviational. In addition, we have also 2 categories of constraints, goal constraints and functional constraints. As you see, goals in goal programming model have to be prioritized. So the high priority is given to the goal, most important goal. Okay. Other lower priorities are assigned to other goals as the farm owner suggests. Variables, as you see, we have PI, which means the priority of goal I, and 2 deviational variables, DI minus and DI plus. The DI minus means the deviation variable from goal I, which shows goal I under achievement. DI plus is also a deviation variable for goal I, which shows goal I over achievement. The data given in table 1 also used to develop the goal programming model for our ecological farm. As you see, we have an object function which is to minimize the deviation from the goal specified. So the objective function in goal programming method is always minimizing the deviation variables from the deviation from the goal specified. Okay. In addition to the objective function, here we have the two categories of constraints. Goal constraints, we have 5 constraints. These are production, profit, expenses, human labor, and machine labor. In addition, of course, the highest priority is given to goal production. So we want to maximize production and also maximize profits. From the other side, we want to minimize capital, human and machine labor. The functional constraints, we have 9 functional constraints. The first one shows the land available. And the other 9 constraints define actually the land size for each crop. For example, X1 is spelled should be equal or greater than 4 hectares, should be planted on 4 or greater hectares, and so on for other crops. Running simplex approach of Excel solver, we obtained 2 solutions. The linear programming solution is shown in the last column of table 2. As you see, the production is more than was specified, so it is 713 tons. The profit is also more than was specified. It is 24,090 euros. Meanwhile, the expenses are less than the farm owner was prepared to pay. The expenses are 24,812 euros. The human labor is 800 hours. Machine labor is 466 hours. The land needed to implement linear programming solution is the whole land available, so 40 hectares. In the last 8 rows of this column, we show the optimal yearly farming plan. So, for example, spelt should be planted on almost 7 hectares, and so on. The goal programming solution is different. As you see here, the results is given here in this column, results. The production is 693 tons. So the underachievement of this goal production, which was specified by 700 tons, is 7 tons. It is underachievement, but still very close. So the underachievement is actually 1%. The profit here you see is less than was specified by 700 euros. Also, the expenses are less than were specified by 1,580 euros. The human labor is 758 hours, so the less for 42 hours. And the machine labor is 456 hours. This is interesting. The land needed to implement this solution is 37 hectares. So the owner has extra 3 hectares to use for other things. And again, in the last 8 rows, we show the optimal yearly farming plan and got from the goal programming method. At the end, we made a comparison between the two solutions. And as you see, the solution, linear programming solution, it enables us to have more production by 20 tons and more profit by 2,792 euros, but it needs more expenses than the goal programming by 1,392 euros. The labor, the human labor is 800 hours. Meanwhile, in the goal programming, we need 24 hours less than linear programming. The machine labor, also we need more machine labor, 10 more hours, 10 hours more than if we use goal programming. Again, in the land used to implement both solution, in linear programming, you need the whole land, but in goal programming, we need 3 hectares less than in linear programming. And at the end, we have listed the optimal yearly farming plans obtained from both methods. And at the end, we may conclude that linear programming method and goal programming methods actually are very good optimization methods and can be used successfully to solve such complex problem as gaining an optimal yearly farming plan. The decision which method may be used actually depends on the strategy and vision of the farm owner. At the end, allow me to express our appreciation to Mr. Tonacic, the owner of the ecological farm in Dol, near Liljana in Slovenia, for his assistance in providing data needed to develop the farm planning using both models. Thank you for your attention and goodbye.